Okay, so our objective for today is right here, to use combinations to count the number of ways an event can happen and to use the binomial theorem to expand binomials. We're actually not going to do that part till tomorrow. A combination is a selection of objects from a group where order is not important. So permutations, there's always going to be more ways because if you reorder it, it becomes a different thing that gets counted. Combinations are a little different. And there is a formula for this, a combination of n objects taken r at a time. It is n factorial over n minus r factorial. I always think the n's and the r's get confused. R factorial. I wrote the wrong thing. I was getting confused because I wrote the wrong thing. Factorial times r factorial. Or there's also a button. There's an NCR button in the same menu that we were using yesterday. So if you hit the math key, it was right next to the one for permutations. So it's math, and then you have to go to the probability menu, and it is, I think, number 3. It says NCR. And so that's another way that you could do that. Okay? So we're going to look at some combinations. There's lots of different story problems that come with this. Did everybody get what they need off of that? All right, so it says, using a standard deck of 52 cards, how many 4-card hands are possible? So it doesn't matter if you're holding like cards 1, 2, 3, 4, or 4, 3, 2, 1, or 3, 4, 2, 1, or whatever. It's still the same hand of cards. So that's what makes this different from a permutation. What order you got the cards dealt to you or that you're holding them doesn't matter. It's just the same 4 cards. And so if you're using the regular formula, since there's 52 cards, you do 52 factorial over 52 minus 4, which is 48 factorial. I'll just go ahead and write that. 48 factorial and 4 factorial. So these two numbers add up to 52. And if you put that into your calculator, you'll get 270,725. The other thing you can also do, if you're using that math NCR key, you could just put in 52 and then the C and then the 4, and it will give you the same number. So there's 2 ways to do the same thing. This is kind of a cool feature that's on your calculator. This is how you would do it if you didn't have that feature. Back when I was doing this, we had to figure out, because we didn't even have the factorial button, we had to figure out, okay, if I have 52 factorial and we're dividing out 4, then I know I don't have to do the 4, 3, 2, and 1. And the 48 you're taking out, and we had to kind of figure out shortcuts so we didn't have to actually type 52 times 51 times 50. Times are a little simpler. The technology's come a long way. But anyway. All right, and what this does when you're dividing this is it's just taking out all of the repeated hands and making sure that you're not counting if you had cards. I guess there's no 1 cards. It'd be ace, 1, 2, 3. Making sure that you're taking out the duplicate 3, 2, 1 ace and 1, 3, 2 ace and all of that. This is just dividing out all of those duplicates since they're actually the same hand. Okay, so down here it says how many of these hands have the same suit. You need to choose one of the 4 suits, then choose 4 out of the 13 cards in the suits. Okay, so a little bit complicated. And so it says how many of these hands have the same suits. So basically what we're doing is, okay, you have 4 cards. They'd all be aces, they would all be hearts, or they'd all be spades, or they'd all be clubs, or they'd all be diamonds. And so there are 4 different suits, right? And you're choosing 1. So you could figure that out, which would be 4 times 3 times 2. Anyway, I'm just going to write it like this for now. And then you want to choose 4 cards that are in a suit to get the hands. So let's say that you have all hearts. How many hearts are there in a deck? 13. And you're choosing 4 of them. So you're figuring out, okay, how many, the suits and the hands, and then you're basically going to multiply those together using the fundamental counting principle. So you could find this number and this number and multiply, or if you want to streamline this, you could type this in times and this in. Either way, you'll get 2,860. Do you guys want to go back and do the in-between steps? Are you good?
Yeah.
Okay. So it's a little bit of our fundamental counting principle going along with. So this, we're choosing one suit. So we're figuring out how many different ways you could do that, and then 4 cards out of that suit. All right. So let's go move on. So another problem about choosing your dinner or lunch. I'm sorry, it's lunch. You are ordering a lunch and can pick from 5 main dishes, 7 side dishes, and 6 drinks. I don't know why there's a question mark there. How many combinations of meals are possible if you pick 2 main dishes out of the 5 they have, 3 side dishes out of the 7, and 2 drinks out of the 6? So basically, you're going to figure out different combinations. So if you start with the main dishes, there's 5 of them, and you're going to pick 2. So you have 5 dishes, and you're picking 2. It doesn't matter if you're picking pasta and pizza, or pizza and pasta, that would count as the same thing. So the 2 takes that part out. And then we're going to do the same thing. We have 7 side dishes, and we're going to pick 3. So it'd be 7 side dishes, but we're only picking 3. But there's 7 to choose from, so that'll give us the number of combinations. And then we have 6 drinks to choose from, and you get 2. I don't know why you need 2 drinks, but so 6 to choose from, and you get 2. I think it just made for an interesting story problem. I don't know.
Or it's like 2 people. It's like, you know.
Oh, it could be like when you go to Applebee's and it's like a. But yeah, that's true. I've done that before.
Yeah.
You can have 2 appetizers, 2
It's
drinks.
like split 2 for 20. That's what it is.
2 for 20, or there's also 2 for 25. I get it. Yeah, that sounds good. All right, so let's look at this one. You can order a sandwich with 1, 2, 3, or 4 different kinds of meats. So that's a little bit different. So because there's more possibilities there. There are 8 meats to pick from. How many are possible? So we have to actually figure out 8 choose 1 plus 8 choose 2 plus 8 choose 3, because these are like separate problems. Plus 8 choose 4 plus all the way up to 8. 8 choose 5 plus 8 choose 6 plus 8 choose 7. 8 choose 8.
Yeah. Only 4.
Oh, it's only 1 through 4. Thank goodness. I just kept going. You're right. It only goes to 4. I should pay attention. And so this would be one that I would probably just type into the calculator. If you want to do each of these separately and add them, you can. I actually have that written down. This comes out 8. So there's 8 different ways you could have 1. We should know that because there's 8 and you're picking 1, right? Mm-hmm. And then there are 28 ways that you could pick 2, 56 ways you could pick 3, and 70 ways you could pick 4. And it comes out to a total of 162 for the final answer. So does that make sense? Mm-hmm. So this is like they're actually asking you to do 4 problems and combine them. And so the big thing is, do you understand why this one's plus and why this one's times? So just slightly different problems. Everybody's good? Mm-hmm. All right. So let's go on to the next one. You are taking a trip. Yay, you. You can pick from 8 amusement parks and 4 beach resorts. Suppose you want to visit 5 amusement parks and 2 beach resorts. How many different trips are possible? Okay, you guys tell me how to set this up.
8C and then 2 times
8C5 because it's 8 amusement parks and 5 amusement parks. So 5, okay?
And then 4C2.
Okay, am I adding or multiplying?
Multiplying.
Multiplying. Good job. You guys are so smart. So we get 336 and that. And then they're going to give us a slightly different problem. If you wanted to visit at least 9 of the 13 parks and resorts, so at least 9 means 1 or 2 or 3 or 4 or 5. Do you get it?
No, it means 9, 10, 11, 12, 13.
Yeah, you're right. 9, 10, 11. Because you're right, I went the wrong way. That would be less than 9. So 9 or more would be 9, 10, 11, 12. That's actually fewer, so thank goodness.
Yep.
So 13 We're picking 9, and then we have 13. We could pick 10, and we're adding on this one because they're different situations. 13C, 12 plus 13C, 13. And if you add all of those up, or if you do them separately, you get 715. So that's how many ways you could choose 9. You choose 10, you get 286. Choose 11, you get 78. Choose 12, you get 13. And if you choose,
You get 1.
there's 1. And if you add them all up, you get 1,093 different possibilities. So slightly different problems. Okay, one more little box to do. You guys all good? Okay, so a movie theater is showing 8 different movies. You would like to see at least 5 of the movies, so 5 or 6 or 7 or 8. I'm going to get it right this time. How many different combinations of movies can you see? Hey, they used the word combinations. How nice.
Yeah.
So if I chose 5 of them, 8C5 would give me how many combinations of 5 I could get out of the 8. If I did 6 of them, this would be how many combinations of 6 out of the 8. 7 of them, and then all 8. And if you do those separately, there's 56 ways to see 5, 28 ways to see 6, 8 ways to see 7, and 1 way to see 8. And if you add all of those up, there are 93 different possibilities, different combinations of movies that you could watch. All right, last one. An ice cream shop has 9 flavors of ice cream to pick from. You would like to pick at least 3 flavors. So at least it'd be 3, 4, 5, 6, 7, 8, and 9. How many combinations can you pick? So 9C3 would be combinations of 3. 9C4 is combinations of 4. 9C5. So I wrote a C instead of a 9. 9C6. 9C7. 9C8. And 9C9. I did not write out all of these numbers, and I did this ahead of time. But if you add them all up and want to practice on the calculator, you should come up with 466.
Oh, bullet.